Here we are in section 5-2, exercises 1 through 9. Identify the property that is illustrated by each statement. Oh, these are from last chapter. Okay. And so it could be associative, which is where we move parentheses, commutative, where we switch, identity, where we multiply by 1 or add to 0, or an inverse, where we do the exact opposite. So let's look at this. 7 plus y plus 3 equals 3 plus y plus 7. Ooh, notice what happened. The 3 switched places here, and the y and the 7 switched places. Both of them switched places around plus signs. So switching order, that is the commutative property, and it is of addition because we did it around a plus sign. So yeah, if there's a plus sign, you can switch them places. So the y and the 7 switched places, and then the whole parentheses around the y plus 7 switched with the 3. Okay, next one. 3xy 7x, 3yx 7x. Oh, that's tricky. Only these two little guys switch places right here. So they switch, so that's commutative. That's good, commute. And this time they switched around a multiplication sign, the commutative property of multiplication. Number 5, 5ar7t, 5ar7t, no switching of orders, but notice that parentheses, the set of parentheses moved, which is legal to do when you have just multiplication. Here you have the associative property of multiplication. It actually doesn't matter where the parentheses are. That's what is being said by that property. Okay, number 4, 17 times. Oh, there we go. That's it right there. Boom. That is the multiplicative identity. Notice he's invisible. You times by 1, it's like you're not doing anything. Number 5. Oh, look at that. That guy is the opposite, which officially is the additive inverse. Negative 21 plus 21, that's what you do to something if you want to cancel it out. All right, number 6. P plus 5 plus 2 equals P plus 5 plus 2. No order switching, they just move the parentheses, which is associative of addition. We're just dealing with addition right now. Good. Number 7. Oh, now we're going to simplify, which means we'll use the distributive property and then combine like terms. Here we have 4st minus 36s as we multiply those in. Now, don't forget when you jump this guy in, minus ts plus 11t. Now, this is where knowledge of these rules is valuable. We have an st and we have a ts. Are they the same thing? Is ts the same as st? It is by the commutative property of multiplication. See, xy, yx doesn't matter. So we can imagine these as a minus st, and it's the exact same thing. So 4st minus st, that's a total of 3 st's. Minus 36s, there are no other s's, and there's no other t's. So there we go. Now, notice because of the commutative property of addition, we can move the 11t here or in front. It could be 11t plus 3s minus 3st minus 36s, or any different ordering of those. Okay, number 8. It's 12x squared minus 60n plus 3n minus 4x squared. What should we do first? The x squareds? Okay, so there's an x squared and there's an x squared term. 12 minus 4 is 8x squared. And then we have a negative 60 and a positive 3. They're opposite signs, so we subtract and we get a 57. But it's a negative 57 because they win. The negative one is stronger. So 8x squared minus 57n. Good. And the final one. 6nj minus 7j. So we're looking for nj's. Remember, it's got to be the whole variable section to match in order for them to be like terms. So 6nj plus 8nj is 14nj. And then that's all the like terms we have. So then negative 7j and plus 11n. And yeah, we could have written the 11n first or the negative 7j first. Good.